Hi, everyone, and welcome to the Enabling Interdisciplinary Engineering webinar. My name is David Horn. I'm the marketing manager for Digilent, part of VNI and Emerson, and I have with me Judy DeLeo and Kara Anderson from iWorx, and we're going to talk through how the new platform ADS Max is going to be a vessel for learning engineering through multiple different courses. If we think about engineering education, the things that come up over and over again in the process of the last 10 or 15 years is making sure that students are getting into classrooms with the ability to have learning in classroom, remotely, doing flip work and just being able to show and work and do a lot of hands-on work in their classroom. So I think that through project-based learning, we give challenging problems and projects in the classroom. We let the students develop their problem-solving skills, and we let the student be the focus and the ones who are completing the work. And I think that once they have done this, they are able to present what they've done. So this is project-based learning in a nutshell. And this is something that has been studied at large. It's we've worked with many universities that talk about the importance of being able to do this and getting their hands-on equipment and really putting the power in their hands of learning. Here's a couple of quotes from some people I worked with at University of Virginia and Georgia Tech, and they are very much proponents of this, and there are hundreds of professors around the country and especially around the world that understand that with these products, getting the students learning is important. So what products do we have? I think if you're familiar with Digilent, then you have seen these products before. We're going to be talking about the two middle ones, specifically the Analog Discovery Studio Max. These products are designed to give professors and students that learning environment that lets them really take their learning to the next level. It's not. It's a way to make practical, hands-on application to classwork materials. So, what makes the Analog Discovery Studio Max different? If you are teaching an electrical engineering course, you'll notice a lot of the things on the screen here. You see B and C connectors. We have the canvases. We have the built-in DMM. We have power supplies, and within this, there's software for a number of different instrumentation that you can use with it. So the purpose of this webinar, talking about interdisciplinary engineering, we have, yes, you can use it as electrical engineering with all the basic oscilloscope and logic analyzer functions. But one of the things we're excited to work with iWorx about is being able to expand that outside of electrical engineering and ECE. So we have power electronics, we have communication systems, energy systems, biomedical, in addition to analog circuits and the measurementation, instrumentation, things that you might be teaching in the ECE classroom. So here's a bit more specs for this. So there's 4 scopes with external BNCs, 100 megasamples per second. It's got a function generator, logic analyzer, pattern generator, got a plus minus 15 volt and 500 milliamp power supply, and a digital multimeter. So again, everything that you're going to need in a classroom to learn on, and our focus is making sure that this is not just in an analog circuits class. It can be, and it's useful there, but it's expanding through to use this. So once you have this board, you can use it in multiple places. here's a few more, a little bit of a walk around of what's on the board. Get you a closer look. And this is being recorded, so we can look at this on your own time. But just know that the functions that are available are more than enough for a classroom setting. And if you're familiar with the Elvis 3, which is NI's old platform, you might recognize some of this stuff. And here's the differences, really. It's not going to have the FPGA processor, which helped us reduce cost. The Analog Discovery Studio Max is actually about half the price of Elvis. So if you are familiar with Elvis and were using Elvis before, the transition to Analog Discovery Studio Max is pretty seamless. We do use a different software, but it is fully NI supported in LabVIEW. So I'll talk about waveforms real quick. So waveforms it's a free to download, works on Apple, Windows, Linux systems. And once you plug the system in, you're up and running on your laptop. So this is great for students in classrooms because they can just plug it in, pull up the windows and make sure that they're using the right instrument. They can set their variables, and it's pretty much, we have some videos on YouTube of getting the download, install, and measuring the signal process in under 7 minutes. So it's very easy to use and easy to get started with, and gives you a real under the hood look at what's going on in circuitry. And this is kind of the base set. And through the Windows SDK, you'll see in the bottom check mark there, LabVIEW, C, C++, Python, all those APIs are available. And so you can access any of those systems. The LabVIEW Waveforms Toolkit gives you the ability to, if you're familiar with LabVIEW or you're teaching with LabVIEW or learning with LabVIEW, this is free to use, and you can get it from the VI Package Manager. So a great addition to those classes and departments that are already set up with LabVIEW. So the thing, in addition to just the base ADS Max, is the ecosystem, and this is what makes it special. As I said, it expands across multiple disciplinary. So we're talking with iWorx today, and iWorx has their own special set of sensors and support for the Analog Discovery Studio Max. And this is what the normal board looks like, and this is removable. So this is Digilent's Canvas Max. So once you take this off, you can switch it to another board. But with iWorx sensors, you actually use this board. So it's full, PCB lines and switches and LEDs and PMOD ports and banana jacks and things that you might need to use to interact with the material that you're teaching. So iWorx sensor kits, there are a couple of them that we have supporting the ADS Max. And first one is the BioMedical sensors kit, and that's what we're going to be looking at today. This includes all the things you see on the screen, and depending on what labs you're working on, it will determine which ones you're going to be using. But I believe that each lab has at least one sensor associated with it. So they also have the chemistry ecology sensors kit, and these are not going to be talked about today. I think it will be referenced today, but there's a number of ways to expand this measurement and data analysis capability into different studies. And that is the end of me. I'm going to actually shuffle over to the iWorx team so they can give you a good look at what we're working with today. And Kara and Judy, would you guys mind introducing yourself?
Sure, I'll start. I'm Judy DeLeo. I'm the Education and Tech Support Specialist with iWorx. I'm also a anatomy and physiology professor at University in New Hampshire. And my job today is to be the teacher, and I'm going to help you guys learn what the ADS Max can do.
And my name is Kara Anderson. I handle our research technical support here at iWorx. And today I'm going to be hands-on walking through as Judy's kind of narrating the setup for you guys.
Okay, so I guess we start, right?
Let's do it.
All right. So the ADS Max board, like David was saying, is really easy to use. It's just really a matter of plugging things in and then getting started with the lab interface. So the first thing to do is going to be to attach the USB cable. The USB cable goes into the back of the ADS Max and then into your USB port right on your computer. And then we'll plug the power supply in. And again, right on the back of the ADS Max and into a power strip. We always recommend it, grounded power supplies. And now we're on and attached and ready to go. So now we're going to connect our BNC cables. We have two BNC cables. They're going to go from channel 1 to the oscilloscope channel 1. And then Kara's going to connect the second one, which is going to go from channel 2 to oscilloscope channel 2. And the last thing we need to do is to connect our variable power supplies. So Kara's going to connect the positive one, and that is red. It goes into the first banana jack port and into the first port on the breadboard. And then Kara's going to connect the negative, and that is going to go into the second port. And this is our variable power supply, and that is banana 1 and banana 2. And then we're going to turn it on. And now the lights are going to come on to show that power is getting to the board. And now we are ready to go. So that board power button in the upper left corner that Kara clicked, it will turn green when the board is actually getting power. And now we're going to interface with LabScribe, which is the iWorx software that is going to allow you to collect data using the sensors that David mentioned earlier. And those sensors are going to be plugged into our iWorx, into the ADS Max, and then interface with LabScribe. So our LabScribe software is, you click it and it's going to open. And this is our LabScribe interface. The first thing that is going to pop up when you open LabScribe is going to tell you that, hey, you did everything right in that first set of steps. And the LabScribe software seamlessly recognizes the fact that you have the ADS Studio Max plugged in and turned on and ready to go. So Kara's just going to click OK. And then, not to get too bogged down with the LabScribe software, we have lots of different things that you can do with this, but we want to just show you how easy it is to start recording using the ADS Max. So we're going to click Settings and then open up one of our many lab activities. And we've chosen to do a couple of them for you today. The first one that we're going to do for you today is the red light, green light. And this uses an event marker. And you'll notice that we have a chip that we're going to basically connect to the breadboard, and our event marker is going to plug directly into that chip. It is connected just opposite where the BNC cables were placed. So it'll snap right into the breadboard, and you can see that Kara is doing that. And then she has plugged in the event marker. And LabScribe is all set to run a specific series of experiments. So this experiment is really looking at very simple data collection on how quickly you can react to certain stimuli. And we have 4 different exercises in this lab as illustrated in our lab directions. These lab directions will open automatically when you choose the settings, and it has step-by-step directions. You'll notice that there are data tables, and we're going to start with the first set of directions. So Kara's going to pop back up to the beginning, and we'll talk really quickly about how this is laid out. It tells you, hey, we're going to do exercise 1, and we're going to look at a single color. And Kara's going to choose the green macro on LabScribe. And then when she chooses that and clicks record, it is going to start showing green squares. And every time you see a green square, you're going to click the event marker, kind of like playing the game of Jeopardy. The faster you click, the faster your reaction time is. This will go for 20 different signals, and you'll notice that the stimuli that are being shown are not being shown on a regular pattern. It's a very irregular pattern, so you don't get used to it. And the idea is, how quickly do you react to certain stimuli? And the idea is that this one looks at specifically red light and green light. And the idea is that, red light, that's stop. You better jam on the brakes of your car. And you don't necessarily need to push the accelerator that quickly to zoom out when it's a green light. But that red light really is very telling on what your reaction time is. And we should have just a couple more. And when it is done, it will stay a white square. And then you'll know that it is completed. And we're going to click stop. And now we've collected a bunch of data, 20 different stimuli reaction recordings. And now it's just a matter of doing some data analysis. How fast did our subject actually react? On the screen, there are 2 red vertical cursors. These cursors are clickable and movable. And Kara is actually moving these cursors to the mark on the bottom of the screen that is made automatically when the green square is shown. And you can see that when she places one cursor on the green mark and one cursor on the square wave that is made from pressing the event marker, it will tell you the time difference between those 2 cursors in the upper right corner of LabScribe. So you can see that that was 350 milliseconds. And Kara's just going to do another one to show you how easy this is. We just click, and it doesn't matter in which order you move the cursors. The left-hand cursor is always the first one, and the right-hand cursor is always the second one. And this reaction time in this case was 360 milliseconds. And Kara, just do one more so we can show people how to move those cursors. And there we go. And this one was 440. So a little slow on the uptake on this one, which is good because you shouldn't be very consistent. And it's nice to be able to see how sensitive the software is to be able to show differences in milliseconds. Once you are done collecting data, it is always important to save your data. And it's very easy. You just go up to File, Save As, and this will allow you to pick a location on your computer, and then you name the file and then click Save. Okay. If you want to continue recording, once you save, you can choose a different macro. Kara, let's just choose that multicolored macro just for the heck of it. And in this one, we specifically want our subject to only react to a certain color. So let's say we only want Kara to react to the green color. So she's going to click record, and now you'll see rather than just red or green marks, we're getting red marks, we're getting blue, and randomly other colors are going to pop up, and there's yellow and red. We haven't gotten a green one yet, but eventually a green one will pop up. Hey, we reacted. And Kara, we can just stop this. We just wanted to show you that the different macros are going to do different things. And if you notice on the bottom of LabScribe, it will tell you the color that was shown. So you can tell whether or not your subject reacted to the colors that you wanted them to react to. So very easy, very fun lab to do. Students really like it. It is a something that gets them enthusiastic about using it because it is so much fun to do. And then we're going to move to show you how to choose a different lab. So once you are done recording your data, you've saved your data, you've done everything you want, you can either close out of LabScribe or you can choose to move into a different lab. Choosing a lab is just as easy as going into settings. And now this time we're going to show a grip strength lab. And Kara's going to click, do we want to save this? We'll just assume that we did. And it automatically opens up the lab. And now we're going to connect different sensors to the board. We're going to use that same pin connector that we were using before, but rather than using the event marker, Kara is going to connect the pressure sensor and the grip force sensor. The pressure sensor gets connected directly to the pins on the breadboard. And then the grip sensor is going to connect directly to the pressure sensor. And it is just a lure lock, so it just screws right in. And now we're ready to record. This lab has a few more directions. So Kara, if you could just go back to that PDF. This lab is a little different because, like I said, it has a few more directions. There is no calibration necessary for the pressure sensor. It's already pre-calibrated to PSI, if you could scroll. And this one is very specific because it will talk about how to hold the pressure sensor properly, and that way you get good proper squeezes. If there's anything that is really important, it will be shown in a yellow pop-out box that says, hey, if this happens, this is how you can fix it. And now we're going to just go ahead and start recording. So this lab actually looks at two things: increasing grip strength and something called fatigue. So if those of you who are familiar with the way muscles act, in order to increase our grip strength, we want to recruit more muscle fibers, and that's just going to make the grip strength stronger. So Kara's going to click record, And then she's going to squeeze 5 times in succession. Each one is going to be slightly stronger than the next. And you'll notice that as Kara is squeezing the bulb, we are making these nice waveforms on LabScribe. And then when she's done recording, we're going to click stop. Now, in the last data set that we recorded, we did some data collection right on the main window. We just looked at time in the upper right corner. For this lab, we're actually going to use another feature of LabScribe, which is our analysis window. And in the analysis window, you're just going to click and drag the cursors, and the cursors will allow you to measure what is known as absolute integral of the strength of the squeeze. Okay. And that's just flipping back and forth between different windows in LabScribe and moving the cursors appropriately. And as you move the cursors, the absolute integral value is going to change, just like when we move the cursors in the main window and time changed. Okay, back to the main window, Kara. And again, the second part of this experiment is something called fatigue. And with fatigue, that is going to be a full squeeze, as strong as you can. And she's just going to squeeze and squeeze and squeeze and squeeze. And you can notice that the longer she squeezes, the strength in her fingers and the muscles in her hand are getting tired, and she cannot maintain the strength of the squeeze. And Kara, whenever you're ready, you can let go. And that's pretty much that experiment. In LabScribe, we do have the ability for students to be able to answer questions about what they've done in the lab. And those questions can be found in the actual PDF document of our lab, as well as in the journal in LabScribe. So Kara's just going to pop open the journal in the editor. Nope. Okay, they didn't transfer over. Sorry about that, everybody. But they are in our PDF. So if you open up the PDF and scroll down, there will be a series of questions after you do the data analysis about what students have gotten out of doing this lab. They should be able to answer those questions. So it is very easy to use the ADS Max breadboard and navigate through LabScribe and be able to measure your data accurately just by clicking and moving around the LabScribe windows with those two cursors. And I think that's all I've got.
Thank you so much, Judy and Kara. So to tell you a little bit more about the Analog Discovery Studio Max, you can get it on Digilent.com. You can order through NI sales channels, NI distributors. You can order the iWorx sensor package through iWorx.com and also on soon to be on Digilent.com, but you can also order on NI.com. If there are any questions, we would love to field those questions for you. But again, thinking about how the possibilities of having the ability, the hardware that you need in one course, being able to use it in multiple courses is, I think iWorx is a great example. This biomedical sensors kit that they have is a great example of how you can do that. And thank you so much for the demonstration, ladies. And does anyone have any questions? If not, we will go ahead and stop recording. Perfect. Thank you all. Oh, yeah, there's one. So Kendrick asks, is this package for biomedical students only? And I'll let iWorx handle that.
Okay, there are two different packages. We have the chemistry package, and we also have the biomedical package, basically. So there are two different packages, but they are looking at how to integrate with the Digilent system. So students can also look at things like electrical filtering when doing these recordings as well. So even if it might be focusing on biomedical, there's many other things that you can do with those sensors. And like I said, there's that other sensor package also that is not biomedical.
Yeah, and I think another benefit of having the labs split up into multiple labs is that you can illustrate different concepts depending on what you're teaching. So I could see some of these labs, depending on what aspect of the lab you're teaching, to be used in circuits as just another way to present the way that circuits or data analysis works. A good question. All right. Well, thank you so much, everyone, for attending. And we will put this recording up and send this recording out to make sure that you guys can share it out. And if you have any questions, please don't feel shy about reaching out to me or to anyone on the Digilent team or the iWorx team to ask questions about the ADS Max or the sensor packages. Thank you so much, and you guys have a good day.
Bye, thank you.
Thank you.